So, Vanakkam. So, we will start our continuation of the engineering seismology lectures. So, last class we discussed about the different earthquake hazard. Okay, so that is like different earthquake hazards. Okay, means the hazard caused by the earthquake. So, we have seen basically about 7 hazards. So, we also discussed about the how these earthquake hazards are distributed in the world due to the deadly earthquake. We have seen the deadly earthquake, basically the earthquake which caused more than death of 10. Okay, those are all the earthquakes are called so deadly earthquake. So, we have noticed that okay, so most of the deadly earthquakes are due to the direct ground shaking. Okay, so the estimation of the direct ground shakings are the prime important. So, then we also seen that the including the tsunami 2004 tsunami earthquake in the calculation and excluding the 2004 tsunami in the earthquake in the calculation. So, we have seen that including of tsunami, basically the percentage of the share by the tsunami is increased, excluding is actually it is less. So, if you remove the direct ground shaking hazard, we also noticed that the tsunami hazard basically caused huge amount of the death, okay, and economic losses. So, which due to the 2004 tsunami mainly we understand. Okay. So, if you want to minimize the human and economic loss due to earthquake is basically you should know how to estimate these earthquake hazards. Okay. So, I basically do research on estimating this earthquake hazard specific to region. So, most of my research okay, so focusing on that, basically I did my BTech project, MTech project and PhD on this earthquake hazard estimations. Okay. So, I can proudly say that I am the one of the leading expert in this area. So, where the estimation done by my team and my research group is more reliable. We also come up with the several new things which is more suitable for a particular region, which is not applicable for universal kind of system. So, particularly India, we try to bring the regional scale and national scale implementation of accurate prediction of the earthquake hazard. My team is actually working towards that. I publish large number of papers. So, those who wish to know about my research on this area, please Google it, Professor Anbaragan IASC. Then you will find my website. From there you can go to my personal publication list. You can find all my published papers on this, okay, where I work on the earthquake. So, I felt after the Bhuj 2001 earthquake myself that I should work on this area, try to contribute whatever way is possible. So, that is why I chosen my first BTech project itself on liquefaction assessment of the Asian game site at Delhi. So, that is more or less the time period where before or the Bhuj earthquake time. Many people even not about knowing many earthquake hazard parameters in the country. So, where I started and we read, we did some project, then I continued my ME project as a seismic microzonation of Chennai. So, then I continued the seismic microzonation with enhanced knowledge and technical experience for the Bangalore. With that I completed my PhD, I became a faculty in IISc. So, I try to work on this area, try to establish myself on development of theoretical knowledge and experimental knowledge. So, where I do have all facilities to predict all these earthquake hazards precisely, particularly ground shaking. So, right now I have not done any work on the landslide and tsunami hazard as I had no opportunity to work on that, but ground shaking I predominantly work where I predict very accurately liquefaction, very accurately amplification, very accurately the direct ground shaking. So, this will help you to reduce this one. So, this experience or this knowledge exchange started within me. So, the similar way, okay, so people after experiencing the earthquake damages in the historic times, okay, people try to understand this earthquake okay, how the earthquakes are happening, why it is happening, how to minimize. So, if you want to see how the engineering seismology itself started in history back, we have to go back to the how people felt on the earthquake. So, the earthquake basically those days are very problematic in the places where people are living close to the coast, particularly place like Japan, where they experience a lot of frequent tsunamis. So, people in those places, they try to see these tsunami waves are killing us, why these tsunamis are occurring. So, what they felt in olden days, okay, so olden days what they felt basically. So, they see that, okay, so the tsunamis are occurring, okay, so they believed that the tsunamis are occurring due to the excess movement of the a particular fish in the sea. It is called as a namazu, okay, which is basically a catfish. Okay, so the catfish family. So, this excessive movement is basically causes a earthquake in this region. They believed that, so because of that they try to kill this fish. Okay. So, you can see that is a fish mongoose selling a flesh from the namazu, whose excessive movement they believe caused the large Yodo. Yodo is earthquake in Japan. So, killed it. The people complained petrifying from their tragedy. So, people believed that catching up this fish and killing will reduce the tsunami effect or earthquake effect. So, anyway this concept is more or less true, and you can also see the similar practice now. Japan is the only country where they kill very big fish when compared to any other part in the world. So, rest of the world, for example India, people do not eat fish beyond some size, okay. But in Japan they kill a big fish, okay, and then cut it as a pieces and eat, okay. That is how that practice still exists, even though the fish is nowhere responsible for the earthquake. After understanding of earthquake, people are understood that nowhere relate fish and earthquake. Even maybe recently there was a news, they told that there was some fish which is staying below the sea, okay, very deep floor level, has appeared in the coast, which may due to the future there may be big earthquake kind of thing expected. This was reported maybe back to like 2-3 months, but there is no big earthquake as on now. So, there may not be direct relation between this fish with the earthquake. But one thing we should very clear that when the animals are very sensitive, okay, including us, very sensitive to the unusual situation around us. So, particularly when these earthquakes are going to happen, these animals are able to sense them in advance and try to shelter themselves. So, we do add that kind of sense, but due to our technology development, less usage of our brain and then our sense, we basically not able to sense this kind of hazard. But animals are capable of sensing that. So, the animals, it is well proved that animals are behave differently when earthquake going to occur. Okay. So, if you watch the animal behavior continuously, one can predict a earthquake. But the problem is that how that particular animal is behaved for the last earthquake and then how it will behave for the next earthquake. Somebody has a history and study, then you can use animal to predict a earthquake. Okay. So, particularly most of you may be seen the movie Dasavadaram. Okay. So, I generally quote some of the classical example which is directly related to the subject. So, during the Dasavadaram movie, actually in the climax scene, okay, before tsunami going to come, so you can see that they show the birds are moving away from the shore. Okay. So, the birds are moving away from the seashore. Okay. And that is not only the movies clippings, there are physical reports are found before tsunami wave going to come. Most of the animal which are tied and holded on some shed try to escape, okay, by forcefully, okay, try to move by pulling that tie and all those things, it try to move away from the coast. That means it sense that there is a tsunami going to come on that particular place. The same way these fishes maybe sense the earthquake before, and due to that it may be come to the shore and moving regularly, okay, to escape from the tsunami effect or whatever. These people might have been watched and misunderstood that movement of this fish causing a earthquake. Okay. So, that is why they try to kill the earthquake. This is how the human start understanding the engineering seismology subject, okay, which is called as a early engineering seismology knowledge. So, then later they also, as you know that, so anything which is not controllable by us, we will make that as a god. Okay. So, as you know that the earthquake also, we have the god called Bhuma Devi, who is responsible for the earth and earth rotation and splitting of earth. So, we used to say that if the Bhuma Devi is angry, she will split a earth and you will go inside. Okay. Our forefather used to curse us, or they used to tell, no. So, she is a woman god which is responsible for the earth and earthquake. The similar way, okay, the Chinese, those days actually the Japan, China and most of the Chinese regions are together. So, they also add a Chinese god, okay, for a earthquake. Basically this is a Chinese god for a earthquake, you can see. Okay. So, this is the god they used to worship from the save from earthquake. So, this is our god where we worship a Bhuma Devi to get good things from the earth and to avoid bad things from the earth. Okay. So, this is the god for basically earthquake. So, basically what is mean by earthquake? So, the earthquake is basically a vibration, sometimes violent, of the earth surface that follows a release of energy in the earth crust. Okay, you should note earth. So, there is a release of energy in the earth crust, which is basically causes a vibration at different places. So, that is called as a earthquake. So, why we need to worry about earthquake? On average 10,000 people die each year due to earthquake, on average throughout the world. On average almost 17,000 persons per year were killed in the 20th century due to the earthquake. So, this was actually increased in the 20th century, the number is gone high. Okay. So, that is where we need to understand earthquake scientifically and try to predict earthquake hazards. So, if you want to understand earthquake, first you have to understand earth. So, most of you may be studied that the earth is a sphere which consists of the different layer. So, when you are talked in the last slide, we told that it is undergo a crust, we said. So, in the earth basically it has a 4 different major layers, or you can say that if you cut a earth as a piece, you can see a group the material present in the earth as a 4 different layers. Okay. So, one is that the inner core, which is having the radius of about 1260. The second one is outer core, which is 2270 kilometer. The next one is mantle, which is 2885 kilometer. The last one where you are resting or you are living is the crust, which varies from 5 to 40 kilometer. So, generally this crust basically divided as a different segment, which is called as a plates. Okay. So, the movement of this segment basically is causes a earthquake. Okay. That we are going to understand how these earthquakes are occurring and why it is occurring. So, the movement of this crust, which is divided as a different plate, okay, is called as a the plate movement, and this division of this plate and then understanding of that, okay, it's called as a tectonic plate studies. Okay. So, the earth is divided into section called tectonic plates that float on a fluid like a interior of the earth. Basically the outer, okay, the inner core and mantle. So, these are all the composite materials which is softer than the earth crust. So, the earth crust basically is the harder material. So, when compared to earth crust, the material below that is basically softer, or it is kind of fluid kind of things. So, fluid means not like water, even you can see that like mercury also is a fluid. Okay, so that kind of a thick, okay, metal which is having the kind of higher this one. So the fluid called as a magma. Okay, so this earth crust sitting top of this magma, which may be inner outer core or inner core or mantle, depends upon the thickness of the plate and depth of the plate. So the earthquakes usually causes a sudden movement of this plate hitting each other or separating each other, and the energy stored in that place is released. Okay, that causes a vibration. Okay, that stress built up is so major cause of the stress built up the two lithosphere actually is causing a earthquake or movement of the tectonic plates. So then the second is also volcanism, like release of this the inner core materials. Okay, the magma to this one causes a volcano, that also causes a earthquake. So the plate tectonic is the major causes of the earthquake. So this you can understand by why it releases energy. You look at very carefully this figure. So as we said that the crust is different plates are formed. Okay, the tectonic plates. So those plates keep moving because the earth is keep rotating, correct. So this movement basically causes a some kind of strain induced in that particular material. Okay, so for example, so this is a material. So I try to bend. Okay, like this I try to bend. So where because I apply some stress because the earth is bending, rotating stress. So when I apply this stress, basically there is a resistance offered from this material. So this resistance, okay, try to compensate the applied energy. Okay, so that applied energy is more than the resistance of the material, then it breaks. So due to breakage, you will find there is a release of energy because whatever the material has the energy, we try to release. That releases a vibration. That causes a earthquake. So the point at which where the dit occurs is called as a focus. The point at which where it occurs is called as a focus. The point where it occurs, okay, that plane is called as a fault plane. Okay. So the projection of that point in the surface is called as a epicenter. So this is, if you talk in the earth size, okay, it's not a small point, it's a bigger surface or bigger area, that is called as a surface trace fault or fault plane. Okay, we will discuss that in detail in the later of this class. So if you want to understand whatever I explained right now in detail, so you take a typical rod. Okay, you can take a typical rod or a stick, you try to push it each other. So it is which indicate that basically you are trying to apply a force. Okay, so you try to push it each other. So when you are pushing that, basically you are applying a external force to this one. So this is, you assume that a plate, a single plate or a plate, this one you apply a force. So because the material has some internal resistance, it try to resist. So when the applied force is, okay, so going beyond the material strength, it breaks. Okay, then it breaks, it become a two section, that during the break there is a release of energy, that is called as a earthquake. That energy carries a vibration waves to the ground. So as you know that, as we told that the top surface of the earth is crust, which is very thick rock and soil formation. So due to rotation of this earth, this individual section plates undergo a stress, okay, or undergo a strain, which is keep accumulating slowly, because instead of applying the force suddenly, you try slowly bend. Okay, so it start accumulating. At one point of time, this induced the force due to this earth rotation and external means, okay, exceed the strength of that particular rock material present in that location. Then when it exceed, obviously it has to break. Okay, so that is what happens here. You can see it breaks. So when it breaks, basically the energy releases and the broken piece become two normal pieces. Okay, then that try to again store a energy. So, these sequences are keep happening, that is why the plates numbers are keep changing with million years. It does not happen in our period of life, because we average live around 60 to 80 years maximum. Okay. It does not happen. This is our geological period. Geological period means you should count your life is nothing in the geological period. Geological period is million years, trillion years. So, those are all the geological periods where this kind of deformations are occurring and the plates are breaking and joining and together and causing a earthquake. So, you can see most of the beautiful features in the earth surface today, all those things are due to earthquake. Okay. Starting from your Himalayan region, beautiful rivers, beautiful valleys, all those things are due to the natural hazard of earthquake. Earthquake only creates, breaks and then displace and then compose. So, all the phenomena earth does. So, the formation of understanding of how the earthquakes are called occurring is called as a elastic rebound theory. So, you apply a force, okay. So, the force exceeding the material capacity like plate strength or rock strength, then when it breaks, that energy stored in that will be released and causing a earthquake. Then the plate became a two pieces that keep continuing. Okay. So, if you understand this, okay, from this it is very clear that if somebody knows what is the strength of material at particular depth and what was the accumulation due to the rotation of the earth, if you relate both of them, you could able to predict a earthquake. But unfortunately, the strength rock is what we told was it varies from crust thickness varies from 4 to 50 kilometer, 100 kilometer, 200 kilometer, depends upon the place. So, knowing of strength of rock at 100 kilometer, 200 kilometer is not that easy. Okay. So, measuring how much strain energy built there due to rotation. If you know today what is the strain energy and what was the rate of strain energy is occurring. So, okay, then if we relate that and this and when it can break, when it can cause earthquake, one can predict. But knowing and measuring that is not that easy. It needs a huge amount of the investment as well as the technological development itself. As on now, the man can able to drill only up to maybe 2 kilometer or maximum 5 kilometer kind of things, not beyond that. But you have to know the strength of material at a minimum 10 kilometer, 5 kilometer, 15 kilometer or 100 kilometer, depends upon the location where these deformations are occurring. Okay. So, if you know that, there is a possibility to predict a earthquake. So, with that, so we understand that the earthquake is actually a vibration caused by the release of energy due to breakage of the rocks. Okay. So, then the point at which where the earthquake origin is called as a focus, the projection of that point to the surface is called as a epicenter. Okay. So, if you have the location where you talk that with respect to the particular place, okay, then you can bring in the concept of hypocenter or hypodistance. Okay. So, for example, so I have the house here or station here. Okay. So, this is my focus point or the hypocenter, this is the epicenter. The distance of this is actually epicenter, a distance of this is called hypocenter. Okay. This is D, this is HD hypocenter, this is the depth of earthquake. Okay. So, these are all the waves, how the seismic waves get generated and propagates in the typical earth sections. So, before going to the study more about the earthquake, we will try to understand some of the terms which we will be frequently using in the subject, the definitions in the engineering seismology. So, I will be defining this whenever we discuss also, but overall we will see that, so that whenever I talk this word, you should not you should know what I am talking. Okay. So, the earthquake is actually the vibration of the earth caused by the passage of seismic waves radiating from the some source of elastic energy is the earthquake. So, the earthquake hazard is any physical phenomena associated with the earthquake that may produce adverse effect on human activities. This includes surface faulting. Okay, the surface faulting is basically the ground displacement at the surface, the ground shaking, landslide, liquefaction, tectonic deformation, tsunami and sieges and their effect on land use. The man-made structures are socio-economical problem. So, anything which causes a risk or hazardous situation to the human is called as a earthquake hazard. So, here we define this one. So, siege, this is actually the tsunami waves comes under the water body. So, water body means you know that in western countries and all they have the very big lake. So, if the lake the earthquakes are occurring, you will get a tsunami kind of wave which is not called as a tsunami, only the sea waves are called as a tsunami, these waves are called as a siege. Okay. So, then the earthquake risk is defined as expected or probable life loss, injuries or building damage will happen in given probability of the some earthquake hazard. If some earthquake hazard is happening, how much the human and economic loss is actually the earthquake risk. Okay. The earthquake risk and earthquake hazards are occasionally used interchangeably. Many people mention earthquake risk as a earthquake hazard as a risk. So, the risk is basically a probable life loss and economic loss due to the earthquake hazard is actually earthquake risk. So, you should not interchangingly use it, but people interchangingly use. Not only this, I will also tell you how the news and other people use the quantification of the earthquake interchangingly when we are talking about the quantification of the earthquake section. Okay. So, the plate tectonic is one of the responsible major source of earthquake. Why? Because most of this breakage of plate and releasing of energy happens at joints, or it's happen it become a joint. So, because of that, so the joints, okay, the geological model which earth crust, the uppermost mantle or lithosphere divided into number of less rigid segments is called as a plate. So, each plate, you can see this plate how this moves, how this plate moves, how this plate moves, how this plate moves. So, each plate moves its own direction, it depends upon the position and the rotation speed of the earth. Okay. So, the earth rotation speed, the magnetic force, all those things also contribute to this kind of hazard. So, you can see if you make the cut earth as a different part of section. So, basically this is your upper crust, this is very responsible for the earthquake, where you can see this oceanic ridge, the trench, okay, then volcanoes and hills and valleys and landforms. So, these are all the common features we can see in the surface of the earth, which is basically occurring due to the breakage and movement of this plate, which is causing a earthquake. So, the seismic wave is defined as a elastic wave generated by a impulse of such as an earthquake or explosion. The seismic wave propagate either along or near the earth's surface. For example, the Rayleigh and Love wave on the surface waves, though the earth interiors P and S wave are the body wave. So, we will be discussing this in detail in the future classes. The time history, the sequence of the value of any time is called as a time history. So, the varying quantities such as a ground motion measurement measured at a set of fixed time and also termed as a time series. So, the time history means the varying quantity with the time is represented as a time history. When the seismic waves comes, basically you can see the displacement of the ground, or you can say that in the form of velocity or in the form of acceleration. If you say the acceleration versus time or velocity versus time or displacement versus time, that is called as a time history. So, that means you can get acceleration time history, displacement time history and velocity time history due to the earthquake you can able to measure. Okay. The foreshocks are the relatively a smaller earthquake that precede the biggest earthquake series concerned in the restricted crustal volume. In a given location, there may be a smaller earthquakes are occurring before big earthquake. Those earthquakes are called as a foreshock. So, aftershock is basically a secondary tremor that may follow a largest shock on a earthquake sequence. Such tremors can extend over a period of week or month or year. So, here you understand what is the earthquake and what is the post shock and what is the aftershock. So, I can say that this is your big earthquake going to occur. So, this kind of smaller events are the your post shocks. The same thing after this, whatever occurring is the we are called the aftershock. So, why these things are very important? So, why these things are very important? So, you may be knowing that very recently there was an article that there was a smaller magnitude of earthquakes are occurring close to the Delhi region. So, this may be the post shock, but the problem is that we do not know how many months or how many days or how many years before the post shock can happen. Okay. So, that period sequence depends upon the region and several things, geological force involved in that kind of earthquake and the thickness of the plate. So, because of that, even though foreshocks are recorded, we are not able to precisely predict a main earthquake. Okay. So, that was the one of the knowledge you should have, what is meant by the foreshock, what is meant by the aftershock. So, the next is active fault. The fault along which the slip has occurred either historical or Holocene or quaternary time, the earthquake focal are located or foci are located, that called as a active fault. So, the fault commonly considered to be active if they have movement one or more times in the last 10,000 years, but there may be also considered active when the assessing the hazard of some application even if the movement occurred in the last 5 lakhs years. So, that means any movement occurred at a particular place, okay, in the 5 lakh years you should consider that fault is active, depends upon the what kind of hazard you want to predict or what for you are going to predict hazard. For example, if I want to predict a hazard for construction of my house, okay, so that for 10,000 years movement will be sufficient. Why? Because my house structure going to stay maximum of 50 years, not beyond that. Okay, so, but if I want to and even if that occurs, only I will collapse my house, only I will die and within my family members will die. But if you are looking for the earthquake hazard for the nuclear power plant or dam, okay, those are all the places where huge amount of the water is stored, and then as you know that the nuclear power plant there is a radioactive material which is never die, as is half-life period itself very large. So, those kind of material if that breaks and releases it causes a adverse effect. If you are looking for hazard prediction of those kind of facilities, you should look for the active fault which has any movement on 5 lakh years. Okay. How do you find out this there is any movement or not? So, you should basically dig and cut and take a material and carbon date it, and if you find there is a contrast materials within the short section which indicates that there is a movement and a fast earthquake which caused this kind of things. The Holocene is a period less than 10,000 years before the present is the Holocene period. So, the quaternary time, so about 2 million years before the present is the quaternary time. The seismicity is basically the geography and historical distribution of the earthquake. So, you should know what is the definition of seismicity. Seismicity means basically you plot earthquake data geographically, okay, and see the distribution of the earthquake, historic earthquake is called as a seismicity. So, the seismogram, the record written by the seismograph, the response of the ground motion produced by earthquake or explosion or any other ground motion source is called as seismograph. So, seismogram is actually a plot, graph is instrument. You should not get confused with the graph and gram. Gram means is basically recorded data by the seismograph. Okay. So, seismometer or seismograph is the instrument, okay. So, could be able to record a vibration or seismic signal. Okay. A seismometer is a damped oscillating mass such as a damped mass spring system used to detect seismic wave energy. okay, or seismic waves. Okay, that is a seismometer or seismogram. So, this seismometer or seismogram is generally it can record velocity or acceleration or displacement. Specifically, it focused on the velocity. Okay, so, measurement is called as a seismometer. If we record only a acceleration, okay, so or when you specify only a acceleration. So, if the record which shows acceleration versus time or detect acceleration at a particular location, that is called as a accelerogram. A record of an accelegraph, okay, is called as a accelerogram. So, the accelegraph is a compact, rugged, relative inexpensive instrument which can record a signal of acceleration. Okay. So, the accelerometer is also called as accelerometer, where it can record what is the acceleration due to that particular vibration, is called as a accelegraph. So, the waves we have seen the seismic waves, waves which is produced. So, the seismic wave basically two type of seismic wave. One is the body wave, the seismic wave that propagates through the interior of the earth, such as a P and S wave are the example. Each type of wave has distinct strain characteristics, okay, is called as a body wave. So, the surface wave, seismic wave that propagates along the earth's surface, the Love and Rayleigh wave is called as a surface wave. So, we will be discussing this in detail on the theory of wave propagation and wave propagation properties. So, the amplification, an increase in the seismic signal amplitude with some range of frequency as the wave propagates through a different earth material, which we have seen the amplification hazard we have seen, like that the increasing in the wave seismic wave is called as a amplification. The decrease in the seismic wave, okay, the wave like the wave amplitude, duration or frequency is called as a attenuation. So, a decrease of seismic signal amplitude as the wave propagates from the seismic source, the attenuation caused by the geometric spreading of seismic wave and the energy and by absorption and scattering of seismic wave in the different earth material. The fault, a fracture along with there has been a significant displacement of two sides relative to each other or parallel to the fracture is called as a fault. So, the fault basically is a seismic event source or earthquake source is actually a fault plane or fault. The length varies from less than meter to the many hundred kilometers, and there are different type of faults are there which we will be discussing. So, again you see that how the fault, like this is basically a fault plane, you can see this is the fault plane. Okay. So, this point basically your focus. So, the surface projection is basically epicenter, the focus also called as a hypocenter, the distance between this is hypocentral distance, this is epicenter distance. So, the fault projected at surface is called as a length of the fault if the length remains same at surface and deeper level. Okay. So, when you make the fault plane projected up to surface and then you draw a vertical line and measure a angle, that angle is called as a dip. The fault plane which makes angle with the north direction is called as a strike. You can see dip and strike, the angle responsible and this. So, these are all the terms which we will be using frequently. So, basically this is the focus. So, this is the hypocentral distance, this is the epicentral distance. So, this is a zone where the rupture is taking place, which is called as a highly stressed region or rupture area. So, the intensity magnitude are the way you can express a earthquake. Okay. So, quantify a earthquake. Intensity as a subjective numerical index describing the severity of the earthquake in terms of its effect on the earth surface on human their structures. So, the several curve exists, but one most commonly used is the United States or modified Mercalli intensity curve or Rossy-Furrer scale. So, we will be discussing about the intensity in detail in the one of the classes. So, the magnitude, a number that characterize the relative size of the earthquake. Magnitude is based on the measurement of the maximum motion recorded by the seismograph. Okay. The sometime earthquake waves are a particular frequency corrected for attenuation and standardized distance. So, the intensity and magnitude are basically measurement of the earthquake or indicative size of the earthquake. So, the magnitude based on the actual record of the seismic record after development of the seismic instrument. Intensity also quantitative, but it is only based on the damage. It is not based on the measurement. Moho is the discontinuity of the seismic velocity that marks boundary between the earth crust and mantle. So, moho is actually a discontinuity between the earth crust and mantle is called as a moho. The period, the time interval requires one full cycle of the wave, or the time interval between the successive crest of the sinusoidal wave train is called as a period. We will be discussing all those things in detail. Frequency, a number of cycle occurring in the unit time. The natural frequency, a discrete frequencies that which the particular elastic system vibrates. Okay, set motion, a single pulse, not influenced by the other external force or by damping is called as a natural frequency. So, the reciprocal of natural frequency is actually a fundamental period. Okay, so this you should know. So, the fundamental period, the longest period for which the structure show a maximum response or reciprocal of natural frequency is the fundamental period. Duration, a time interval between the first and last peak of the shaking ground motion is the duration. Amplitude is the wave, 0 to peak value is called as a amplitude, a wave like disturbance. The first motion on a seismogram, that direct ground motion as a P arrives in the seismometer, P wave arrive in the seismometer. The upward ground motion indicates expansion of the source region and downward movement indicates contraction. So, these details are required to know that the whatever waves recorded in the seismogram is compression wave or tension wave. So, if you look at a typical earthquake record at particular place, you can see like this. So, basically when there is no earthquake, like this you will have the straight line movement. Then when the earthquakes are occurring, so you first you will experience a P wave. Okay. So, then you will experience a S wave. So, then followed by you will also experience a surface wave, depends upon the location. This is a typical earthquake plot where you can see P, S, okay, waves and followed by the surface wave. So, this wave amplitude and the amplitude wave height depends upon the where instrument and earthquake origin is located, the distance between that. Some places you can see P wave is very high, some place you can see S wave is very high, some place you can see surface waves are very high. Surface waves are very high at some places. So, isoseismal referring to the line of map bounding points of equal intensity particular earthquake. So, isoseismal is actually if we connect all the equal intensity at particular earthquake, that is called as a isoseismal. So, the mapping of all intensity isoseismal lines is called as a isoseismal map or intensity map. Seismic zonation basically is the geographical delineation of the area having different potential for hazardous effect of the future earthquake. So, the seismic zone, last class I told you that Indian seismic code present is not up to state of art knowledge. So, the seismic zonation should consider all the different earthquake hazard in the region and map those hazard and group them based on the similarities. Okay, that is called as a seismic zonation. Seismic zonation can be done at any scale, national, regional, local and site scale. The source, the geological structure that generate a particular earthquake, the explosion used to generate a acoustic or seismic wave is called as a source. So, as we said that earthquake is a vibration. So, if it is the natural one, it is a geological based tectonic earthquakes. If it is the man-made one, it may be due to the explosion. The Fourier amplitude spectrum, the relative amplitude at different component of frequency that are derived from the time history of the Fourier analysis is called as a Fourier amplitude spectrum. Geotic, okay, is the referring to the determination of size and shape of the earth, precise location points its surface is called geotic. Phyloseismic is actually I told you that phyloseismology study on last class. So, phyloseismic is referring to the prehistoric seismic record as inferred from the young geological sediment. So, studying the old earthquake is called as a phyloseismic based on the geological deposit aging. Sites I told that oscillating of surface of the enclosed body of water owing to the earthquake shaking. Okay, tsunami in the enclosed body is called as a sites, it is not a tsunami. Stress drop, the difference between the stress occurs of fault before and after earthquake is called as a stress drop. This stress drop is specific to region. So, before earthquake and after earthquake, what is the stress difference is called as a stress drop. So, because of due to the release of energy, that is depends upon the region. Some location will have the very high, some location will have the very low, which will be useful. We will discuss in the source characterization time. So, with these definitions, you should go through all of them. We will also frequently define and use this definition. So, we close this class. So, these definitions you need to know, so that whenever we refer and we discuss, you should be aware. Okay. So, to this class we basically discussed about the what is mean by earthquake and how earthquakes are understood in the historic time, that is the earlier engineering seismology. Okay. We have seen that people used to kill a Namazu fish in Japan, assuming that the fish movement caused the earthquake. Okay. The fish might have moved due to the earthquake, but not caused the earthquake. Okay. So, then we try to understand how the earth interior and which causes a earthquake. So, we basically the elastic rebound theory, okay, so which gives a clear idea how the earthquakes are occurring. So, by knowing this, now I have the question for you. So, can earthquake occur at a specific place, or earthquake can be expected anywhere in the world? Okay. Can I say that a particular place I cannot expect earthquake by knowing the elastic rebound theory? So, that is the question. You think and try to come back with the answer on next class. We will, while starting the class, I will tell you what is the answer. So, with that I thank you. We will see in the next class.